In this second tutorial, we'll be going over hormones, the HPG axis, and male and female hormonal control. Let's start off with the hormones. The two main categories of hormones are lipid-soluble and water-soluble. The lipid-soluble hormones are androgens, estrogens, and progestogens. The water-soluble hormones are GnRH, gonadotrophin-releasing hormone, FSH, follicle-stimulating hormone, LH, luteinizing hormone, and oxytocin. Oxytocin doesn't come up much, and it controls the smooth muscle contractions of specifically like the uterus and the vagina during childbirth, and it's kind of this positive feedback loop where you keep pushing harder and harder until the baby comes out, and that's kind of the end of that one. Now there are three main sex steroid hormones. Number one's androgens, which are in males and females, but mostly in males. Estrogens, which are in male and female, but mostly in females. And progestogens, which are female only. The main type of progestogen is progesterone, and that's role is in preparing and maintaining a pregnancy. Now the two main types of androgens are testosterone and 5-alpha dihydrotestosterone. That last one, 5-alpha DHT, is just a more potent version of testosterone. And testosterone has roles including the male sex development, spermatogenesis, sexual behavior, and muscle development. Estrogens, like I said, mostly in females, are the main types of estradiol, estrone, and estriol. Estradiol is the main type, and it's created by the granulosa cells within the ovary. Estrone, many sites, but it's mostly in like fat cells. That's why both male and female can have estrogen. And estriol, which is mostly involved in pregnancies. The main roles of estrogens in the body are female sex development, development of the endometrium, maintenance and regulation of the menstrual cycle, and bone growth. Now I'll move on to this HPG axis, and that means the hypothalamic pituitary gonadal axis. Basically how the brain, this is a cross section of the brain, controls like the gonads and the reproductive cycles. So we start in the hypothalamus up here. Use this. GnRH is released by the hypothalamus, gonadotrophin releasing hormone, and that flows down here. We can see that's the hypothalamus. It flows down and it acts on the anterior pituitary. And the anterior pituitary releases FSH and LH. Those two come out, 1 and 2. And then these go and act on the gonads, which are the ovaries in the females or testes in the males. So those go out whoop, and act on these two things. And then those release sex hormones. Okay, testosterone from the testes, and then estrogen from the ovaries. And then both of these things, boop, boop, will go and they'll do a negative feedback loop onto these two. So that's what's happening in the body. I will just draw that onto the flow diagram up here. So the sex hormones, they do a negative feedback. Negative, negative. So that's basically saying that we've received this FSH and LH, and then we've produced our hormones, and that you don't need to produce as much anymore. So it's this homeostasis, trying to keep everything in control. And then we'll finish with that. And now we'll focus on the female and male hormonal control. So we need to just orientate ourselves first. So this, again, is the hypothalamus and pituitary, which we can see from up here, which is this little part within the brain. So basically the brain's controlling what's happening in the ovary. And then this is, this is basically a little uterus and the ovaries. And this is an expanded view of an ovary. And then if you can imagine that these are just the same egg but at a different time. So that's in like week 1, then later, then it just keeps progressing, and this is just a big circle. So that's primordial follicle, primary, secondary, mature. And then this is where ovulation has occurred, and the egg has been kicked out of the ovary, and the corpus luteum has been created. And then there's the corpus albicans, which is basically scar tissue. Okay, now that we have an overview, we'll go into the hormonal control. So up here, I've represented all of the hormones with a little symbol. So these dots are the GnRH, which is the gonadotrophin releasing hormone. So that hormone is released, and it flows down, and it interacts with the anterior pituitary, which releases LH, this circle, and FSH, this star. So these hormones are pumped out, and they flow out into the body, and then they get to the ovary. And we can see that these hormones will be produced at different times because they act on different things. So FSH, follicle stimulating hormone, you can see what the hormone does by its name. So it's follicle stimulating. So it wants this primordial follicle to grow. It stimulates it to become a mature follicle. So you can see there are 4 little arrows, therefore it's acting on this primordial one, then it will act on this primary, then the secondary, and the mature, and it's just being released so that this will be matured. And we'll go over the concentrations of the hormones down here. We'll just get a quick overview first. So we can see FSH would be in the first part because it's acting on these follicles. Now the luteinizing hormone, if you look at its name, break it down, lutein, which is like yellow. So its main role is it wants to create this corpus luteum. So it's saying, okay, it's talking to this mature follicle and it's going, I see that you're big enough, we can kick out the egg and now you can become the corpus luteum so that we can make this progesterone. And the brain wants this to happen because progesterone is important, we can see from here, for preparing and maintaining a pregnancy. So once this mature follicle is ready to become the corpus luteum, this luteinizing hormone says, okay, you can become the corpus luteum now and you can start producing this hormone because we need to prepare the body for a baby if it's going to happen. Now that we have a quick overview, we'll go down here. So we know that FSH, before that, we can see that this is basically the hormone concentration. So if you were to take a blood test and you were to check how much hormones are in the body, this is what it would look like, this graph. And you wouldn't see GnRH because that's up in the brain. You can't really stick a needle in your brain and get some of that hormone out. So we just get these ones that circulate in the body. Okay. Now we'll go with FSH, which is color-coded as blue. So this little star, it's released by the brain and it's saying we need to create a new follicle because the last follicle, it's the start of a new cycle, didn't work, so we need to make another one. So it's being released and at the start it's low because it's the start of a new cycle, but then it peaks up. That's because we need to tell the body it's time to make another baby. So it creates a peak in the graph because there's beginning of the stage. And that's only at the beginning because that's when the follicle's growing. That's only half of the cycle. The bottom half, you can see it's kind of mostly the corpus luteum which is doing the job. So we can just do a little peak there and leave it at halfway now because we're at halfway. Now, at the same time, we know that estrogen is being released. We'll draw it up here. And estrogen is this little diamond. So these cells up here are producing estrogen. And it's because estradiol is created by the granulosa cells. And the granulosa cells only start to grow in this kind of primary, secondary, and mature. So it's mostly this part here where there's the most estrogen. So you can see that it will be low level, these low levels. But then once that follicle has started to grow and that granulosa cells are bigger, the amount of estrogen increases. Increases, but it's like, wow, these cells are big, therefore there's heaps of estrogen. An important thing to note is that at a certain point, this goes from negative feedback to positive feedback. Because up here we remember that sex hormones normally do negative feedback, but once this cell has matured enough and it's producing enough estrogen, we can the body knows that this cell is ready. It's ready to become the corpus luteum and it's ready to release that egg. And the brain knows that because it's detecting these levels. And once it reaches a certain point, it's like, okay, the body's ready to create a corpus luteum. It needs to get ready for the baby. So it's switched to positive feedback. So that way more FSH and LH is being pumped out. And that's why at this time, LH has been pretty low because it has been necessary. But then once that peak has been reached and it's positive feedback, this LH is like, whoa, okay, I need to come out. And it peaks. And that peak in LH is what causes this because if you see here, the LH is acting on the mature follicle and it's causing it to ovulate. It's like, okay, let's get rid of this egg and let's become this corpus luteum. You can see 1, 2, 3, and there's 3 stages. That's why there's a big peak here. And that's what causes ovulation to occur and for this corpus luteum. So remember, LH, luteinizing hormone, creates this corpus luteum. Now, after that spike, levels go down because it's like, okay, I've done my job, I've made that. Now, the important thing that happens next is that we know that this is important in creating progesterone because that little heart is producing progesterone and the heart means that it loves babies. That's what it's doing, it's trying to prepare for a baby. That's why, if you see here, there's been low levels of progesterone, but once that LH peak hit, progesterone levels increase. It's like, okay, let's get ready. But then it will decrease if there's no baby. Go down like that. And this is what this decrease is. And then also, you see that there's a decrease in estrogen, and it comes back up here because this corpus luteum is also creating estrogen, which is another thing important in getting ready for the baby. If you can see up here, it also has a role in maintaining the endometrium. The endometrium is what's feeding what would feed the fetus. So it picks up, then that would also come down. And we'll also do LH and FSH. That would also peak, but since the brain's smart, it's like, okay, there's no follicles that we really need to get ready, so you don't need to peak as much as FSH, so it doesn't peak as much, and they all go down. And they all go down over here because there's no baby, and it's sad, so it becomes like a scar tissue, and it doesn't release anything, so it's all down here. Now we'll move on to males. That was a bit to like go through, so if you want to like take a break and think about it, that'll be good. You can also, it's important to understand why everything's happening, because this diagram can be kind of confusing if you just look at all the squiggles. You need to understand why it's happening, and if you link it into a big picture, so basically the body wants to get ready for a baby, that's what the reproductive system's all about. That'll be good before you move on to this. Now moving on to the male system. We'll start up here with this, like an overview of everything. This is up in the brain again. This is up here, this little hypothalamus and pituitary. Everything's a bit out of scale, but that's it up there. And then if we look over here, this is basically like the testes, and I've done like a magnified view of everything. So this is like a big view of the cells within it. Okay, now if we look, we can see this blue stuff, that's just connective tissue. It's basically supporting everything. And then in the connective tissue, we can see a Leydig cell, and that's the cell that produces testosterone. And then we can see the Sertoli cell, which is in, so imagine like that's the tubule, and like that's the connective tissue around the tubule. And then these are Sertoli cells, and they create androgen binding protein, and then inhibin. Okay, now that we have an overview, let's go look at the hormones. Up here, the little dots, that's GnRH. So that flows down and it goes to anterior pituitary, and the anterior pituitary faces LH, that circle, and FSH, the star. Let's focus on LH for now, because it's the same process over here. Different hormones act on different cells. So basically each cell only is looking for that one hormone. It's like, I only want to listen to this one guy. Over here, the follicles only listen to the follicle hormone, and then this one only listen to the luteinizing hormone if it wants to become corpus luteum. So same thing over here. Different hormone, different action. So luteinizing hormone, it works on the Leydig cells. So that's a good way to remember it. LL, Leydig luteinizing hormone. So the luteinizing hormone will bind to the Leydig cells, and the Leydig cell will release testosterone, which we know is the main androgen or main hormone within the males. And then that's kind of end of story there. And we'll quickly go over to FSH. FSH will go through and it will bind to these Sertoli cells. And when it binds to Sertoli cells, the Sertoli cells release androgen binding protein and inhibin. This androgen binding protein is important because it binds to this testosterone and it allows the testosterone to go throughout the body. Since this testosterone is lipid soluble, it's good, it can go between the cells and float around there, but it can't go in the blood. It's like trying to mix water and oil, it doesn't work. That's why I need to add the protein onto it so that it can go out to the body. It can do everything like the muscle development and the sexual behavior and everything. But the testosterone can also become 5-alpha dihydrotestosterone, and that's a more potent version, and that can also go around the body and do its thing. But this androgen binding protein can go both out and help the testosterone go around the body, but it also can go in. So this is the tubule, and it brings the testosterone, it binds, and then the testosterone is able to bind to like the sperm, and that's what allows them to undergo spermatogenesis. So if you didn't have testosterone, you couldn't undergo spermatogenesis. If you didn't have androgen binding protein, you couldn't do it either because the cells can't get the testosterone, and that means that the person can't make sperm. So these are the two main important hormones of the system. Now, like everything, it needs a negative feedback loop, because if there's too much going on, there'll be too much being created. And it's like if you have too much of your medicine, it's like overdose. But if you have just enough, it's good, it makes you better. So that's why inhibin is released. Inhibin goes back up to the anterior pituitary, and it says, okay, we have enough, you can stop now. So it tells FSH, since FSH works on the Sertoli cells, we don't need as much. And then this testosterone, it also feeds back. So Leydig cells, it goes up, once it's binded to the androgen binding hormone, it goes to the brain, it says, okay, I don't need as much. And it works on both the hypothalamus and the anterior pituitary. But it's like, okay, we can slow down everything. So that's the end of that system. Everything in this hormonal control comes back to this HPG axis. So it's like a negative feedback loop, except for in the females where it can turn to a positive, depending on what stage of cycle, because the brain knows, okay, we need to get that corpus luteum so that we can make a baby, because the brain's smart and it knows what to do. Okay, let's do a quick recap. Two main type of hormones, lipid soluble, water soluble, androgens, estrogens, progestogens, GnRH, FSH, LH, oxytocin. The sex steroid hormones, the two main ones, and then the progestogen, which is important in females for maintaining a pregnancy. There are different types, and they have different roles in males and females, and they're in different levels within male and female. And the HPG axis, which is a negative feedback loop, which we can see is the brain acting on the gonads, and then the gonads telling the brain that they've received their message and that they don't need to produce as much anymore. Now, female control. So if you just remember that there are different stages, and it's a cycle. So it starts with a small cell and it grows bigger, and then it ovulates and then becomes this corpus luteum, which is important because the body wants to make babies, so it needs to prepare the body for that. And then if you link what hormones are controlling this, because basically hormones are what's controlling the body, but then the body is just sitting there and needs to be told what to do. So you need to remember what is telling what to do. So FSH, talking to the follicles, LH is talking to the mature follicle to become that, corpus luteum. And you just link that in with the levels over time. So if you remember at the beginning, FSH peaks because it's trying to stimulate follicles, and because the follicles are growing, there is an increase in granulosa cells, which increases the amount of estrogen because estrogen is produced by the cells. And then at a certain point, it switches to positive feedback, which makes the brain pump out more of this luteinizing hormone, a little bit of the FSH, but not as much because it needs the LH. LH is the one that's important because you need to make that corpus luteum. And after that, progesterone increases because you need to prepare the body for having a baby. And estrogen also increases because the corpus luteum also makes estrogen. And then if nothing happens, they will drop off. Then in the males, it's the same hormones, but they act on different cells. Leydig cells, testosterone. Then Sertoli cells, FSH, and inhibin. Then inhibin and testosterone go back and they do negative feedback. That's the end of this tutorial. In the next one, we'll go over more of the gross anatomy and more on the development of the gametes.